In this 2017 DD session, Immersive Scott Rigby explains why it's valuable for developers to have a nuanced understanding of player autonomy. Rigby discusses how autonomy is often mean, giving players freedom, which can lead to player frustration and disappointment rather than satisfaction. He outlines an accurate blueprint of what autonomy actually means and shares best practices to avoid design pitfalls. It was an insightful talk that's definitely still worth watching, so developers should not miss the opportunity to do so now that it's freely available on the official GD YouTube channel. In addition to this presentation, THEGDC Vault and its accompanying YouTube channel offers numerous other free videos, audio recordings, and slides from many of the recent Game Developers Conference events, and the service offers even more members-only content for DD Vault subscribers. Those who purchased all access passes to recent events, like DD Vault, already have full access to DD Vault, and interested parties can apply for the individual subscription via the DD Vault subscription page. Group subscriptions are also available. Game-related schools and development studios who sign up for DD Vault Studio subscriptions can receive access for their entire office accompanied by contacting staff via the THEGDC Vault Group subscription page. Finally, current subscribers with access issues can contact DD Vault technical support. Naughty Dog is known for shipping games that are both engaging and highly cinematic, and at next year's Game Developers Conference in March you will get an inside look at how the magic is made. Specifically, you will get to see Naughty Dog's story. Animator Mary Ann Hayden pull back the curtain on the design of Uncharted. The Last Legacy is charming. Cinematisla felt riding her Game Narrative Summit session on Design vs. Story, how Uncharted, The Last Legacy, addressed the elephant in the room. This promises to be a fun, informative talk that will give you an inside look at the story and design process at Naughty Dog. You will learn from both a design and production standpoint how an animal originally intended as background became a vital part of the narrative, and the useful vehicle for bonding two characters together. For more details on this talk, and many more, check out the NLINEGDC 2019 session scheduler. There you can begin to lay out your GD 2019, which takes place March 18th through the 22nd at the newly renovated Moscone Center in San Francisco. Bring your team to GD. Register a group of 10 or more and save 10% on conference passes. Learn more. For more details on NGDC 2019 visit the show's official website, or subscribe to regular updates via Facebook, Twitter, or Gamasutra and DD are sibling organizations under parent company Informa. In the following essay, the leading technical artist of NEC's Russian development partner Benzi Games, Roman Tursky, describes the rendering process and the materials used for the characters' equipment in the mobile game Shadow Fight 3. In addition, he reviews some of the tricks used for setting up the environment. Shadow Fight 3 is an RPG action game developed on the basis of the Unity engine. The game was released on iOS and Android in November 2017, and since then the number of installations has exceeded 50 million. To reach such a large audience, the development team had to perform well in optimizing the game, and as a result of their efforts, the game runs at 60 frames per second on most modern devices. Journalists and players often praise the visuals of Shadow Fight 3. In this article, I will give you insight under the surface of the game and reveal how we manage to achieve this visual quality, rendering a frame. There are many factors that directly affect the performance of the game and the number of frames it can display per second. One of the most important factors for us was the number of jaw calls used per one frame in the game. Let's take a closer look at the concept. During the rendering of a game frame, of each static group of objects sharing the same material, Unity uses jaw calls and overlays them on each other. Each jaw call requires CPU resources, so an important step in optimization is to reduce the number of these calls. Our goal was to minimize the number of calls to 100 per game frame on average. This GIF shows how a single frame is rendered. The first step of rendering in Shadow Fight 3 is drawing the dynamic shadows of the characters and the glow effects for the luminous elements on the armor and weapons of the characters. Both of these processes have their own peculiarities and they should be explained in detail. Shadows, in addition to the main camera used for the main frame, an additional orthographic camera projector is installed on the scene, designed to draw the shadows from the characters onto a separate surface we call a shadow receiver. This camera follows the midpoint between the opponents and creates their projection onto the plane based on their current position. The result takes the form of an alpha texture, which replaces the same texture with the rendered result of the previous frame in the dynamic material of the shadow receiver object. This approach helps us to avoid the need to calculate real shadows and draw them on all models in the location, which would have a significant effect on the overall performance. Shadow receiver surface. For this frame, the process took 20 render calls. Glow. The process of creating a glow effect on the armor and the weapons of the characters is similar to the process of creating dynamic shadows. A blur cup is created around the model with luminous elements. Glow effects are projected on it every frame, based on information stored in the blue channel of the RGB texture of the material of the glowing object. That means the blue channel acts as a mask for projecting the glow. You will see more about this below. In the section about character materials, the blur is applied and the information is saved as an alpha texture, which replaces the texture with the result for the previous framing. The dynamic blur cup material. Blur cup. In this frame, the glow process calculation took 15 jaw calls. Please do more to blur the effect. Much is done. First of all, the parts of the armor and the weapons of the characters are rendered, and we render all parts of the location of the foreground, then the background objects, and then the background itself, which is a plane with a texture size of 1024 x 512. They are followed by particle systems, some small details of the foreground, and, finally, models using overtext animation. More on this below. Eventually, in the next two jaw calls, the calculated and previously drawn shadows and glow effects are applied. UI. In addition to the cameras mentioned above, we use another one during our rendering process, which is intended to render the user interface. Unlike the main and orthographic camera projector, it is not unique for each scene. It exists permanently during the entire game session. Thus, after rendering the scene, the characters, and all of the visual effects, UI is rendered and placed on top of the main frame, all along with the dark vignette on the screen edges. Main camera render, UI camera render, final frame render. In total, the rendering of the final frame of the scene requires 92 jaw calls for character's equipment material. To create the material of the character's armor, a few textures with a resolution of 512 x 512 are used. diffuse, RGB masks, matcap, an additional diffuse map for the shadow form, as well as a small noise texture marsh mask used to create the effect of the character's transition to the shadow form. Diffuse map is just a texture of the armor itself. So let's discuss the rest. Since the RGB texture conventionally consists of 3 color channels, defined by the value 0 or 1 for each pixel, it is convenient to use it for storing various data about the material at each specific point of the map of the object. In our case, the RGB texture channels, masks, contain information for the following processes.